As we're working on this impulse momentum theorem, we have here for problem number 3, we're going to continue with this baseball that now is being thrown in and is going to hit, the batter is going to hit this baseball with a certain amount of force, this 1320 newtons of force, and it's going to go in the opposite direction. So once again, we want to draw out the problem before you start working on it so we have an idea of what's occurring. So we know the baseball is moving to the right initially and to the left finally. It's going in the opposite direction. And we're being asked about this change in momentum and that final velocity. So we're going to use the same principle of that we had in number 1 of calculating that change in momentum. And then we're going to use the same steps that we did for number 2 to calculate this final velocity. So the change in momentum, which is that impulse, force times the change in time. We know the force of this 1320 newtons. We know the time that this was in contact was 9 times 10 to the negative 3 seconds. We take all these, we multiply them together, and we're going to get a value of 11.88 Newton seconds. And this is where we have to ask ourselves, which way was this force acting? Because we do know this momentum changed because the ball was moving to the right and then it's moving to the left. So we know this bat right here had to hit this ball in this direction. So we know the force had to be going to the left due to the bat. So we know this bat had a force onto the ball of a negative 1320 newtons, giving us this negative 11.88 Newton seconds. So from there, now we have this change in momentum. So we have the first part. Now we're going to be asked to find the second part about this final velocity. Just like in number 2, we're going to use this equation here, where we're once again asked to find this final velocity. So this is why I like to set up the equation in variable form like we did in number 2. So now we can just use it again here in number 3. We know the final velocity is equal to that impulse divided by the mass plus the initial velocity, where now the impulse is this negative 11.88 Newton seconds. The mass is still the mass of the baseball of 0.140 kilograms, and we're going to add in the initial velocity. That's how fast the ball was moving when it came to the batter. It was moving at that 42.4 meters per second. So you're going to take these values, add them up. You have a big negative of 82 or 84 point something, and what we're going to get is a negative 42.5 meters per second. So this would be the final velocity that the baseball would be feeling, or would be traveling with rather, after the baseball bat was to hit the ball. The baseball bat hit the ball with this 1320 newtons of force. So now we're being asked this question, well, how much force did the ball exert on the bat? Well, we know then if there was a negative 1320 for the bat on the ball does 1320 newtons of force onto the bat. And we know this simply by Newton's third law. For every action, there's an equal and opposite reaction. So the baseball hits the bat equally hits the baseball in the opposite direction.